Welcome to Wizznotes.com Mathematics Video Tutorials.
Mock exam 1, question 11b. It reads, given that the matrix A, B, C, D is the matrix representing a reflection in the line y equals x, we have to evaluate the values of A, B, C, and D. Now this is basically asking us to derive the matrix for the reflection over the line y equals minus x, and that will be one of the common transformation matrices that we are supposed to know. Others would be reflection over the y-axis, reflection over the x-axis, reflection over the line y equals minus x. We also are required to know transformation matrices for rotation, like 90-degree clockwise rotation, 90-degree anti-clockwise rotation. We're also required to know the transformation matrix for size transformation of varying scale factors, scale factor half, scale factor 2, what have you. Normally scale factor by A, given by scale factor K. But in this one they're asking us for reflection in the line y equals x. But just to give some background, generally when we're asked to derive one of the common transformation matrices, right, when asked to derive a common transformation matrix, we normally use the points. That is a good way of doing it, is to use points on the y-axis and on the x-axis, and these are the points that will help us. Points on the x-axis 1, 0, or we can use a point 0, negative 1, 0 on the x-axis, or we can, and then we use a point 0, 1 or 0, negative 1 on the y-axis, and we normally do the transformation for one of the points on the x-axis and one of the points on the y-axis in order to work out the values for A, B, C, and D. Alright, so that is very important. Alright, because the only way you're going to ensure you get all the values A, B, C, and D is to use one point on the x-axis, one of these points, 1, 0 or negative 1, 0, and one point on the y-axis, 0, 1 or 0, negative 1. So let's look at the current question, which is reflection over the line. Reflection over the line y equals x. And what I'm going to do, I'm going to put up a graph. I'm going to put up a graph that will explain what is happening and how you go about doing it. Let's look at this graph. Alright, and let me explain. Now we said what we do, we use a point on the x-axis and apply the transformation that we're required to find to that point. Now this is the line y equals x passes through. Y equals x means that x values and y values are the same on the line. So where x is 1, y is also 1, and where x is 0, y is also 0. So this line passes through 0, 0, and also passes through the point 1, 1. So there is our line. Alright, so we say we apply 1 point on the x-axis. So let's say we're using this point on the x-axis and applying the reflection in the line y equals x. This point is 1, 0, 1, 0. And if you reflect this point over the line y equals x, it will come to this point on the y-axis, which is now 0, 1. Alright, so reflection of this point will come to this point. Then we have to use a point on the y-axis. So why not? Why not just use this point as well? So if we reflect this point now back over the line y equals x, it will come back to this point, which is 1, 0. So the reflection of 0, 1 over the line y equals x will take us back to the point 1, 0. Alright, and then what we do now, we use the matrix to apply the transformation. We know what the result is, and therefore we can work out the values of A, B, and C. So let's look at this question that we were asked to find. Alright, but first let us put in words what is happening. Alright, so what is happening is that when the point 1, 0 is reflected over the line y equals x, the image is 0, 1. That is, when this point is reflected over this line, the image is this point. And when 0, 1, which is now the point on the y-axis, 0, 1 is is reflected over the same line, y equals x, the image is 1 0. The image is 1 0. So what we're saying is that we're going to use this point as the point on the x-axis that we're supposed to use, and then we're going to use this point on the point on the y-axis that we are supposed to use. We always use one point on the x-axis and one point on the y-axis, and the points we are supposed to use are these points. Always use one of these points, either 1 0 or negative 1 0 on the x-axis, and for the y-axis points we use 0 1 or 0 negative 1 on the y-axis, and that is to derive transformation matrices for our reflections over the common lines or for our rotation. In other questions we might look at a rotation, but okay, so back to this one. If the matrix ABC represents these reflections that we're talking about, these reflections, right, then for the first one, which is the 1 0 reflecting over the y-axis to 0 1, right, when we set up the matrix, what we would get is this. We would get that when you apply the matrix to the vector matrix for this point is 1 0, so the column matrix for this point is 1 0. When you apply the reflection, the result is 0 1. See, the result is this point 0 1. That's what we are saying. And then if you do the multiplication to evaluate values here, you see that you get two of the values, and that is why we have to apply it to one point on the x-axis and one point on the y-axis, because one of the transformation will only give us two of the values, right? So let's see, a multiplied by 1, this 0 here is given by a multiplied by 1 plus b multiplied by 0. So a times 1 is a, b times 0 is 0, so therefore a equals 0. That's it, a equals 0. And then to get this one, we'd have to multiply this row by this column here. So it is c multiplied by 1, that's c, and then d times 0 is 0. So c times 1 is c would be equal to 1. So we have c equal 1. So that's two of the values. And then when we apply the transformation now to the point on the y-axis, that is why we are saying you must do one on the x and one on the y to get the other two values. Right? So when we now apply the transformation now to the point on the y-axis, it reflects back to this point here. Right? So we say that the transformation matrix that we're using, A, B, C, D, multiply by the column matrix for the point that we're reflecting. In this case, it is 0 1. The result is going to be 1 0. So this is the result matrix 1 0, and then we do the multiplication, right, to evaluate the values here, and we're going to get two different values because we're now reflecting from a y-axis point. So what we're going to have now is a times 0 is 0, b times 1 is b, and that is equal to 1. So what we're saying is that this one is equal to this row multiplied by this column. So a times 0 is 0, b times 1 is b. So we're saying that b is equal to 1. There it is, b is equal to 1. And then to get this 0, we would have to multiply this row by this column here. So it is with c times 0 is 0, and then d times 1 is d. Right, so d would be equal to 0. C times 0 is 0, d times 1 is d. So that's d would be equal to 0. So there it is, d equals 0. So now we have all four values. We have a, we have b here, we have c here, and we have d here. We have all the values. So then we can basically write the solution line, which is a, b, c, d is equal is the matrix 0 1 1 0. So this matrix 0 1 1 0 is a matrix which represents a reflection over the line y equals x, and that's your answer. So thanks for visiting Wizznotes, and you can come back for more solutions in mathematics. Okay, bye.